Okay, in the question number one, we have a type of assertion and reason. So assertion is saying that when radius of a circular loop carrying current is doubled, then its magnetic moment does not change. See, we have a formula of magnetic moment as m is equals to nia. So it does depend on the radius of the circular loop because it is depending on the area. So area will be pi r square. So magnetic moment will change if we change its radius. Assertion is wrong. Okay. Now let's come to the reason. Reason is saying magnetic moment is independent of the area of the loop. So we can see from the formula it does depends on the area of the loop. So reason is also wrong. So D option, which says both assertion and reason are false statement, is absolutely true. Okay. Now let's go to the next question, the question number two. So question number two is saying that a current carrying circular coil has radius r. The distance from the center of the coil on its axis where the magnetic field will be 1 by 27th of its value at the center of coil is. So we know that magnetic fields formula is mu naught ni r square upon 2 r square plus x square to the power 3 by 2. So we can say b1 by b2 will be equals to r square plus x2 square to the power 3 by 2 upon r square plus x1 square to the power 3 by 2. Okay, and we have given this value is 1 by 27th of its value at the center of the coil. So at center of the coil, we know it is mu naught ni by 2r. So if we put this value here, then mu naught ni by 2r, the distance from this where the magnetic field will be 1 by 27th of its value at the center of the coil. So 1 by 27 into this value should be equals to mu naught ni r square upon 2 r square plus x square to the power 3 by 2. So this term got cancelled it out, mu naught ni got cancelled it out. This 2 got cancelled it out. So r square plus x square to the power 3 by 2 comes out to be 27 r cube. If we cross multiply them, if the power goes 1/3, then r square plus x square to the power 1 by 2 will be equals to 3r. If we square on both sides, then r square plus x square will be equals to 9r square. So x square comes out to be equals to 8r square. So x comes out to be equals to 2 root 2r. So B option, which says 2 root 2r, will absolutely be correct answer. Okay. Now let's go to the next question, the third one. In the third question, we have given in an overhead power line, current is flowing towards east direction. We have asked to find out the direction of magnetic field above the power lines. So direction of magnetic field can be found out by right hand thumb rule. So first we will draw this situation. So current is flowing towards the east direction. So if you put your fingers towards the east direction over here, then your palm will show the direction of magnetic field in the south direction. So towards south is absolutely correct answer in this situation. Okay, let's go to the next question, the fourth question. The fourth question says if a charged particle is moving in a circle with speed v in a uniform magnetic field with a time period t, then okay, so time period's formula in this situation we know is it is 2 pi m by q. Now we know that mass and charge of a particular particle is fixed, and we have also given that the magnetic field is uniform, means it is constant. So we can see it does not depend on the velocity. So we can say t is directly proportional to V to the power 0, as it is not depending on the value of V. Okay, so B option should be correct answer. Now let's go to the next question, the fifth one. The fifth question we have asked the unit of intensity of magnetization. So it is a theoretical question. We just have to directly learn it. Its unit is ampere per meter. So A option, which says ampere per meter, is absolutely correct answer. Now let's go to the next question, the sixth one. In the sixth question, uh, we have given the torque acting on a magnet of length 5 centimeter and pole strength 20 ampere meter kept in a magnetic field of 10 to the power minus 3 Tesla at an angle of 30 degree with field is okay. So torque we know is m cross b, and this can be written as mb sin theta. mb can write is pole strength into length. So pole strength we have given 20 into length we have given 5 centimeters. So it would be 5 upon 100. So it comes out to be 1 ampere meter square. Okay. So torque comes out to be mb sin theta. So m we have 1, and magnetic field we have given 10 to the power minus 3 into sine 30. So this can be written as 10 to the power minus 3 divided by 2. This we can also write it as 5 into 10 to the power minus 4 Newton meter. So C option is absolutely correct answer. Now let's go to the next question, the seventh one. The seventh question is a theoretical one. We have to choose the correct statement among the following. So A option is saying that an EMF can be induced by time varying magnetic field in a coil. See, EMF's formula we have is minus d phi by dt. So magnetic flux we can write B dot A. So either by varying the magnetic field or by varying the area of pressure, we can change the EMF. So A option which says an EMF can be induced by time varying magnetic field, it is absolutely correct. B option which says an EMF can be induced by moving a circular coil in a variable magnetic field, it is also correct. So D option which says both 1 and 2 is absolutely correct answer. Now let's go to the next question. Next question, the eighth one. The eighth question is saying that current passes through an induction coil of inductance 2 Henry, and we have given 2 Henry, is increasing at the rate of 2.5 ampere per second. So di by dt, we have given 2.5 ampere per second. We have asked to find out the magnitude of potential difference. So EMF we know is minus L di by dt, as we have to find its magnitude. So we will consider its magnitude only. So L we have 2, di by dt we have 2.5. So EMF induced or the potential difference we can say is 5 volt. So C option which says 5 volt is absolutely correct answer, right? Now let's go to the next question, the ninth question. In the ninth question, we have given two coils C1 and C2 are placed near each other and current changes by 2 ampere in coil C1. So I1 we have given 2 ampere and the magnetic flux changes by 0.8 Weber in coil C2. So flux into we can write 0.8 Weber in C2. The value of mutual inductance we have asked. So M we can write phi 2 upon I1. So this will be 0.8 divided by 2. So mutual inductance will be 0.4 Henry. So A option will be correct answer in this situation. Okay. Now let's go to the next question, the 10th one. In the 10th question, we have given the we have asked to find out the permeability of the material of a rod whose magnetic susceptibility is equal to 699. So Xi we have given 699. Now we know that magnetic permeability mu is mu naught into 1 plus xi. So mu naught we know is 4 pi into 10 to the power minus 7 into 1 plus xi we have given 699. So it will be 4 pi into 10 to the power minus 7 into 700. So this comes out to be, mu comes out to be 28 pi into 10 to the power minus 5. So D option will be correct answer in this situation. Now let's go to the next question, the 11th one. The 11th question, we have given the magnetic flux linked to a coil is phi is equals to T cube plus 2T plus no, where T is in second. We have asked to find out the magnitude of induced EMF in the coil at T is equals to 3 seconds. So we know that EMF is minus d phi by dt. So if we differentiate the flux, then it will be 3t square plus 2t. As we have to consider its magnitude only, so we will take its magnitude and put the value of t as 3. So it will be 3 into 3 square plus 2 into 3. So it will be 27 plus, so it was differentiation of 2d will be only 2. It was only 2. So it will be 27 plus 2. So EMF comes out to be 29 volt. So C option which says 29 volt is absolutely correct answer. Now let's go to the next question, the 12th one. The 12th question, we have given a charged particle moves through a magnetic field perpendicular to its direction. Then we have asked about the momentum and kinetic energy of the particle. Okay, so when charged particle moves through a magnetic field perpendicular to the direction, so it will move in the circular motion with the constant speed. Velocity is not constant because its direction is continuously changing, but we can say its speed is constant. So we can say its kinetic energy, which is half mv square, is constant, but its momentum is not constant because its direction is continuously changing. So C option which says momentum changes, but kinetic energy is constant, it's absolutely correct answer. Now let's go to the next question, the 13th one. In the 30th question, we have given same current I is flowing in three infinitely long thin wires along positive x, y and z direction. We have asked to find out the magnetic field at a point 0, 0, A would be. So first we will draw this situation. So this situation is something like this. This is x. This is y. We have to assume this in 3D. This is z, and there is a point on z axis which is 0, 0, A. Now for the infinite wire, we know that magnetic field's formula is mu naught I by 2 pi r if the distance is r. Here in this case, the distance is a. So you have to find the direction of magnetic field by right hand thumb rule. You have to put your thumb in the direction of current. So one current is flowing in this direction, one current is in this direction, and one current is in this direction. So magnetic field due to the wire on the z axis should be 0, and there is only magnetic field due to the current in the wires on x and y axis. So if you find out its direction, the net magnetic field comes out to be mu naught I by 2 pi a I cap minus j cap. So C option should be correct answer in this situation. Okay. Now let's go to the next question, the 14th one. In the 14th question, we have given the magnitude. We have asked to find out the magnitude of magnetic force on a current carrying semicircular loop moving in a transverse magnetic field as shown in the figure will be. Okay, so the loop is given something like this. This is uniform magnetic field. So this is radius r. This is radius r. and current is flowing like this. We know that magnetic force formula is BIS. Here this length is the distance between the 2 points, this point and this point. So this distance we have is total 2r. So F comes out to be BI into 2r. So it would be 2BIR. So B option is correct answer in this situation. Now let's go to the next question, the 15th one. In the 15th one, we have asked to find out the path of a charged particle entering in a uniform magnetic field, making an angle 60 degree with the field. Okay, so this situation is something like this. If we consider magnetic field's direction in this path, then its velocity's direction will be in this 60 degree. So it will move in this path. This path is known as the helical path. So D option, which says helical, is absolutely correct answer. Now let's go to the next question, the 16th one. In the 16th question, we have given the permanent magnetic moment of the atom of a material is zero. The material must be. So this is a theoretical question. You can see in the theories, this material would be diamagnetic. So material must be diamagnetic in this situation. So B option should be correct answer in this situation. Okay. Now let's go to the next question, the 17th one. The 17th question, we have asked to find out the magnetic field due to a short bar magnet of a magnetic dipole moment M and length 2L at a point B, which is at a distance R, where R is very, very greater than L, from the center of the bar magnet as shown in the figure. Okay. So this is the bar magnet we have given, south, north. This is 12. This B, R, 30 degree. So we know that its magnetic moments formula is mu naught upon 4 pi m upon r cube under root 1 plus 3 cos square theta. So all of the values are given as it is. M we have given, R we have given. We just have to put the value of theta over here. So theta we have given is 30 degrees. So cos 30 we know is root 3 by 2. So it's the square would be 3 by 4. So this would be 1 plus 9 by 4. So this comes out to be mu naught upon 4 pi m upon r cube under root 13 by 4. So under root 4 comes outside. This becomes 2. So 2 into 4 becomes 8. So this will be under root 13 by 8 mu naught m upon pi r cube. So this will be the value of the magnetic field. Sorry, this will be the magnetic of the magnetic field. So D option, which says magnetic field, is absolutely correct answer. Now let's go to the next question, the 18th question. In the 18th question, we have given if a solenoid has length L, area cross section A, and number of turns per unit length N, then its self-inductance is equals to. So L we know is number of turns into flux upon I. So as we have given number of turns per unit length, so N we can write N into L, phi we can write B into A upon I. So magnetic field due to a solenoid we know is mu naught Ni. So this I got cancel it out. L comes out to be mu naught N square Al. So A option is absolutely correct in this situation. Now let's go to the next question, the 19th one. In the 19th question, we have given a bar magnet of length 12, magnetic moment M and force strength small m is broken perpendicular to its length into two pieces in the middle We have asked to find out the magnetic moment and force strength of each piece will be. Okay, so situation is something like this. So force strength we can write one is minus m, other one is plus m. Its length we have given is 12. Now it is cut perpendicular to it. So the result would be something like this, and this would be minus m plus m. So and its length will be L. In the earlier, the magnetic moment was m into 2L. Now m dash becomes m into L. So this will be m by 2 and pole strength remains same as you can see. So B option which says m by 2 and m would be correct answer. Okay. Now let's go to the next question, the 20th one. In the 20th question, we have given magnetic flux is changed to a coil of resistance 5 ohm. As a result, an induced current is developed in it, which varies with time as shown in the figure. We have asked to find out the magnitude of net change in flux. We have asked to find out the net uh, change in flux. Okay, so E we know is minus d phi by dt. Its magnitude is d phi by dt. So from here d phi we can write e dt. So in place of EMF we can write E is equals to IR dt. This we can write R integration I dt. So delta phi comes out to be R into area under IT curve. So R we have given this 5 ohm, and area of this triangle it would be half into base into height. So it would be half into 0.2 into 6. So this would be 5 into 0.6. So delta phi comes out to be 3 Weber. Okay. So B option should be correct answer. Got it? Now let's go to the next question, the 21st question. In the 21st question, we have given a metal rod of length 2 meter is rotating about its end with an angular velocity of 100 radian per second in a plane perpendicular to a uniform magnetic field B. The potential difference between the ends of the rod is 60 volt. Then we have asked to find out the magnitude of the magnetic field. So its direct formula we know is half B omega L square. If we put all the values, then delta V we have 60 volt. B we have to find out. Omega we have 100 and length we have given 2. So it would be 2 square. So this got cancel it out. This got cancel it out. This will be 3. So B would be 3 by 10. So B comes out to be 0.3 Tesla. Okay. Now let's go to the next question, the 22nd one. In the 22nd question, we have given a conducting rod of length 10 centimeter is moved with speed 3 meter per second in a uniform transverse magnetic field of magnitude V is equals to 2 Tesla, and the potential difference across its two ends. So EMF we know L dot V cross B, right? As in the given situation, all of the physical quantities are mutually perpendicular, so we can directly write down BVL. So B we have given 2 Tesla, B we have given 3, and length we have given 10 centimeter. So we have to convert this into meter. This got cancelled out. This will be 6 by 10. So EMF would be 0.6 volt. Okay. Now let's go to the next question, the 23rd one. In the 23rd question, uh, we have asked about the mutual inductance of two coils can be increased by. Okay, so we know mutual inductance is N phi 2 upon I1. So it is directly proportional to number of turns. So if we increase number of turns in the coils, then it is increases. So second statement is absolutely correct. Third is saying that winding the coils on steel core, it is also correct. If we wind the coils on a steel core, then mutual inductance will be increases. So B option, which says 2 and 3, is absolutely correct answer. Now let's go to the next question, the 24th one. In the 24th question, we have asked to find out the equivalent inductance between points and for the given combination of the inductor. Okay, so this we have given, this is something like this. This is this, and this also we have given. This is 2 Henry, this is 2 Henry, this is 2 Henry, this would be 2 Henry, and this is B. Okay, so we can see these are parallel to each other. And equivalent of the inductor works same as that of the resistance. In parallel, we can write 1 by L equivalent is equals to 1 by L1 plus 1 by L2 plus 1 by L3, 1 by L3. As we can see, these are in parallel and of same magnitude. So we can write directly these as 2 by 3 Henry. Equivalent of them will be 2 by 3 Henry. Now we can see this 2 Henry and this 2 by 3 Henry are in series. So in series, we can write L equivalent as L1 plus L2. So this will be 2 plus 2 by 3. So this would be 2 plus 2 by 3. So this comes out to be 8 by 3 Henry. So equivalent inductance would be 8 by 3 Henry. So D option, which says 8 by 3 Henry, is absolutely correct answer. Now let's go to the next question, the 25th one. In the 25th question, we have given a deuteron and an alpha particle, with same momentum and perpendicular to uniform magnetic field. And we have asked to find out the ratio of their respective circular paths, ratio of the radii of their respective circular path. So R we know is mb by qb. So this we can also write p by qb. So as we have given, they entered with the same momentum. So p and b are same. So r1 by r2, we can write q2 by q1. Now we know that charge on alpha particle is 2 times that of electron and charge on deuteron is now 1 time that of electrons. So R1 by R2 comes out to be 2 by 1. So B option is correct in this situation. Now let's go to the next question, the 26th one. In the 26th question, we have given if VB is equals to 10 volt and instantaneous current is 1 ampere is flowing in a circuit which is increasing at the rate of 10 to the power 3 ampere per second as shown in the figure, then we have to find charge on the capacitor. So VB we have given 10 volt, instantaneous current we have given 1 ampere, and di by dt we have given is 10 to the power 3 ampere per second. Okay, so first we will draw this situation. This is earth, this is resistance, this is inductance, this is capacitance, this is 6 volt, this B is 10 volt. So if it is earth, then this would be 0. This is 1 ohm, this is 1 millihenry, this we have given 1 microfarad, this is 6 volt. Current is flowing like this, 1 ampere. So we will go from, let's suppose this is A point, from A to B. and applying the KVL. So along the direction of current, the potential in the resistance would be negative of IR. So it would be minus 1 into 1 minus L di by dt plus Q by C plus 6. It would be equals to VB. So if you put all the values, then it would be minus 1 minus L. We have 1 millihenry. So it would be 10 to the power minus 3 di by dt. We have 10 to the power 3 plus Q we have to find out. The 6 VB we have given 10 volt. So this got cancelled it out. Q by C comes out to be 10 minus 6 plus 2. So this would be 6. So Q will be 6 into 1 microfarad. So this becomes Q is equal to 6 microcoulomb. Q comes out to be 6 microcoulomb. Right? So C option is absolutely correct in this case. Okay, now let's go to the next question. The 27th question, we have given a long straight current carrying wire is placed in horizontal plane near a square loop carrying a current of 1 ampere as shown in the figure. We have asked to find out the net force on the loop is. Okay. So first we will draw this situation. This situation is something like this. Current is flowing in the anti-clockwise direction 1 ampere. So when the direction of currents are in opposite, then force would be repulsive. So let's suppose this is F1 in this case, and this is F2. This is F3 would act in this direction downward, and F4 would be this. As distance of F3 and F4 are equal, so F3 and F4 are equal, so this got cancelled it out. So net force comes out to be F1 minus F2. Now we know that F is BIL. So in this case, B due to infinite long wire we know is mu naught I by 2 pi r. So F net comes out to be, if we put all the values, then it would be mu naught upon 2 pi. Current is same in both the cases. It is 1 ampere. Okay, it is 1 ampere, and R in this first case it is given 2 centimeter, and this we have given 8 centimeters. So in the first case it is like 2 centimeter. So this will be mu naught uh, I by 2 pi R. B into current we have this 1 ampere, and length of this will be 8 centimeter. Okay. Now we will write the same thing for the F2. So this would be mu naught upon 2 pi I we have again 1, and in this case R we have this 2 plus 8. This would be 10 centimeter, again 1 into length. Again we have this 8 centimeter. The centimeter thing will get cancelled it out. So it will be mu naught upon 2 pi. If we take mu naught upon 2 pi common, then it would be 4 minus 4 minus 4 by 5. So this would be mu naught upon 2 pi into 16 by 5. So in place of mu naught upon 2 pi, we can put 2 into 10 to the power minus 7, because we know mu naught upon 4 pi is 10 to the power minus 7. So we can just write it like this. So mu naught upon 4 pi becomes 2 into mu naught upon 4 pi becomes 10 to the power minus 7. This 2 multiplied this 16 by 5. So this comes out to be 32. It would be 4 comes outside. It was 10, and this would be like ultimately. I think we have done some mistake. Mu naught upon 2 pi by 8 minus mu naught upon 2 pi. The distance was 10 in this case, and the I1 I2 in this case would be this 2 and 2. So this should be 2 over here. There should be 2 over here, and I1 I2 would be 2 over here. So because this is 2 ampere and this is 1 ampere, so it should multiply 2 to it. So this should be 8 minus 8 by 5. So this becomes 32 by 5. So this will be 32 by 5. So this becomes 64 by 5 into 10 to the power minus 7, right? So net magnetic force comes out to be 12.8 into 10 to the power minus 7. So this would be 1.28 into 10 to the power minus 6 Newton. As we can see, the F1 is greater than this F2, and we can see F1 is repulsive. So net force should be repulsive. So B option should be correct answer in this situation. B option is absolutely correct. Now let's go to the next question, the 28th one. The 20th question, we have given two conducting rods of length L and 4L undergo translatory motion in opposite direction with velocity 4v and v respectively, velocity 4v and v respectively on a conducting surface as shown in the figure, and there is a uniform magnetic field B into the plane of the paper. The potential difference between the highest point P and Q of the rod is. So in case of the rod Q, the potential difference will be minus B into 4V into L. So it will be minus 4BVL. In case of P, it is plus B into V into 4L. So it will be plus 4BVL, as they are of opposite sign. If we find out the difference between them, then it will be 4 BBL minus 4 BBL. So the difference would be 8 BBL. So B option, which says 8 BBL, is absolutely correct answer. Okay, now let's go to the next question, the 29th one. In the 29th question, we have given a charged particle enters a uniform magnetic field with velocity vector at an angle of 37 degree with the magnetic field. We have asked to find out the pitch of the helical path followed by the particle is p. The radius of the helix will be. Okay, so pitch p we know is time period into horizontal component of the velocity, which is v cos 37. So t we can write 2 pi r by the perpendicular component of the velocity, which is v sine 37. V cos 37. So V got cancel it out. P will be equals to 2 pi r on sine 37 we know is 3 by 5 into 4 by 5. So 5 got cancel it out. R will be equals to 3b by 8 pi. So B option should be correct in this situation. Now let's go to the next question, the 30th one. In the 30th question, we have given a circular current carrying loop of radius 5 centimeter. Radius we have given 5 centimeter and having 50 turns is, and we have given 50 is placed in xy plane as shown in the figure. Uniform magnetic field B is equals to 2 I cap Tesla exists in the region if current in the loop is 3 ampere. I we have given 3 ampere. Then match the following columns and take the correct option. In the A part, we have asked to find out magnitude of magnetic moment. So magnitude of magnetic moment we know is NIA. So N we have given 50. I we have this 3 ampere, and area we can write pi r square. So this will be 150 into pi into r we have 5. So it would be 5 upon hundreds whole square. So this will be 150 into pi into 25 by 10 to the power 4, right? So this will be Ni. Okay. So we have to write in the form of pi. So we can write this as 3 pi into 50 into 25 would be this 1250 on 10 to the power 4. So this would be 3 pi by 8 ampere meter square. So it matches with the column 2Q. We have asked in the B part, we have asked direction of magnetic moment. So direction of magnetic moment, we know, is in the direction of area vector. Okay, so area vector would be outward to the plane of paper. So as the circle is in the xy plane, the area vector should be in the z axis. So our option, which says along the z axis, would be correct in this case. In the C option, we have asked to find out the magnitude of the torque. So magnitude of the torque will be MB, right? So MB have calculated 3 pi by 8. Magnitude of magnetic field will be 2. So torque will be 3 pi by 4 Newton meter. So it matches with the P option. In the D option, we have asked to find out direction of torque on the loop. So torque will be M cross P. If you do the cross product of M and P, you will get the direction along the y-axis. So it matches with the S. So correct option would be D option, which is A is Q, B, R, C, P, and D, S. Okay. Now let's go to the next question, the 31st one. In the 31st question, this is a theoretical question. In this question, we have given Curie temperature is a temperature above which material X becomes material Y. So X and Y respectively are. So we know that above the Curie temperature, the ferromagnetic material becomes the paramagnetic material. So D option, which says ferromagnetic and paramagnetic, is absolutely correct answer. Okay. Now let's go to the next 32nd question. The 32nd question, we have given in a coil of area A is equals to 20 centimeters square, we can write it as 20 into 10 to the power minus 4 meters square, and 50 turns with magnetic field directed perpendicular to the plane changing at the rate 10 to the power 3 Tesla per second. So dV by dt, we have given 10 to the power 3 Tesla per second. The resistance of the coil is 20 ohm. We have asked to find out the current in the coil. So I, we know, is V by R. So this we can write d phi by dt upon R, or we can write it as A into dB by dt upon R. So if we put all the values, so we have to multiply by number of turns also. So number of turns we have given 50 into area, we have 20 into 10 to the power minus 4 dB by dt, we have 10 to the power 3 upon R, we have 20 ohm. So if we solve all these, then this got cancelled out. So I comes out to be 5 ampere. Okay. So B option, which says 5 ampere, is absolutely correct answer. Now let's go to the next question, the 33rd one. The 33rd question, we have given two conducting circular loops are concentric and lie in the same plane. We have asked to find the current in the outer, we have given the current in the outer loop is anti-clockwise and increasing with time, then the induced current in the inner loop is. So this situation is something like this. In the outer loop, the current is in the anti-clockwise direction. So we have asked the induced current. So from the Lenz's law, uh, the direction of current should be in that direction in which it should avoid it. Okay, so it should decrease it. Okay, so direction of the current in this will be in the clockwise direction. Okay, so clockwise, which says C option, is absolutely correct answer. Now let's go to the next question, the 34th one. In the 34th question, we have asked to find out the SI unit of power factor. So power factor's formula we know is resistance upon this impedance R upon Z. So they both have same units. So power factors have no unit. So D option, which says no unit, is absolutely correct answer. Now let's go to the next question, the 35th one. In the 35th question, for an electromagnetic wave, the direction of propagation of wave is in the direction. Okay, it is a theoretical question. Its direction is in the perpendicular of electric field and magnetic field, means E cross B. So this will be the answer. Now let's go to the next question, the 36th one. In the 36th question, we have given a DC ammeter shows 1 ampere reading for a circuit containing coil connected to a 100-volt DC source. The same coil carries 0.5 ampere current when connected to a 100-volt 50 hertz AC supply. The inductance of coil is nearly. So first we will find out from the above given data the resistance we will find out. So resistance we can write V upon I. So it will be 100 upon 1. So it should be 100 ohm. Okay. In the next AC source, for the AC, we can write I is equals to V upon under root R square plus XL square. XL is the inductive reactance. So we have given, in this situation, we have given 100-volt AC source. Under root R square, in place of R, we can put 100 square. XL we know is omega square L square. Now, omega we know is 2 pi F. So 2 pi frequency we have given 50 hertz, so it would be 100 pi. Right? This should be 100 pi. So the reading in this case would be 0.5 amperes. So this should be 1 by 2 is equals to 100 upon 100 square plus omega square L square. So if we cross multiply them, then it would be 100 square plus omega square L square, this should be equals to 200. If we square on both sides, then it should be 4 into 10 to the power 4. So omega square L square comes out to be 3 into 10 to the power 4. So omega L comes out to be root 3 into 10 to the power 2. Now omega we have calculated this 100 pi. So 100 pi should be equals 100 pi into L should be equals to root 3 into 10 to the power 2. So this got cancel it out. L comes out to be root 3 upon pi Henry. So A option should be correct in this case. Now let's go to the next question, 37th one. The 37th question, we have given in a series LCR circuit, the capacitance is changed from C to C by 4. For the resonating frequency to remain unchanged, the inductance should become. So we know that resonant frequency is formula is 1 upon 2 pi under root LC. So now C becomes C by 4. So for the resonating frequency to remain same, the multiplication should remain same. So L should be 4L. Means L should become say 4 times so that this 4 and this 4 got cancelled out. So L should become 4 times. A option which says 4 times is absolutely correct answer. Now let's go to the next question, the 38th one. In the 38th question, we have asked that which of the following statement is correct for a transformer. Okay, so we will check all the options. In the A option, we have given a step-up transformer increases the power. It is wrong because step-up transformer increases the potential. B option says a step-down transformer decreases the current. But it is wrong because it decreases the value of potential. C option which is saying using laminated coherent transformer reduces energy loss. It is absolutely correct because this is theoretical one. It is true for it. Okay, so C option should be correct answer. Now let's go to the 39th one. In the 39th question, we have given a plane electromagnetic wave propagates in vacuum where amplitude of electric field is 30 volt per meter. E naught we have given 30 volt per meter. We have asked to find out the amplitude of the magnetic field. So C we know is which is speed of light is E naught upon V naught. So from here we can write V naught is equals to E naught upon C. So E naught we have given 30 volt per meter. Speed of light we know is 3 into 10 to the power 8. So this should be 10 to the power minus 7 Tesla. We know. Okay. Now let's go to the next question, the 40th question. It's A option is correct in this situation. Now let's go to the 40th question. In the 40th question, we have asked the electromagnetic rays which is widely used to disinfect water. Yes. So it is UV rays. It is what? UV rays. This is theoretical question. Just have to directly learn it. A option is correct in this case. Now let's go to the 41st question. The 41st question, we have asked to find out the reading of the ammeter in the circuit shown. So reading of ammeter will be I is equals to V upon under root R square plus XL minus XC's whole square. So if we put all the values, so V we have 110, R we have this 55, XL we have 15 minus XC we have 50. This got cancelled out. I come to be 110 on 55. So I will be 2 ampere in this case. So A option should be correct answer in this scenario. Okay, now let's go to the 42nd question. The 42nd question, we are given in an LCR circuit. R we have 10 ohm, XL inductive reactance we have 20 ohm, and XC capacitive reactance we have 10 ohm. We have asked to find out the average value of current for a complete complete cycle for source voltage V is equals to 20 sine 30t. So for the complete cycle, we know average value for the current as well as potential for a sine waveform, it is 0. For the complete cycle, it is 0. So D option is absolutely correct in this case. Now let's go to the next question, the 43rd question. In the 43rd question, we have asked out of the following, choose the ray which does not travel with speed of light in vacuum. So students, it is beta rays. It is a theoretical question. We just have to directly learn it. D which says beta rays is absolutely correct. Let's go to the next question, the 44th one. In the 44th question, we have asked which among the following has the largest wavelength. So it is radio wave. Radio waves has the largest wavelength among these options: radio wave, X-rays, ultraviolet rays, infrared rays. So A option is absolutely correct in the 44th question. Now let's go to the last question, the 45th one. So in the last question, 45th one, we have given an electromagnetic wave of intensity I is equals to 30 watt per meter square is incident on this surface of area A is equals to 2 meters square if the surface is perfectly absorbed. We have to notice that when it is perfectly absorbing, then the amount of momentum transferred to the surface in 10 seconds would be. Okay, so change in momentum delta P we know is energy per unit speed of light. So energy we can write intensity into area into time. This upon C. So I we have given this 30 watt per meter square, area we have given 2 meters square, time we have given 10 seconds. C we know is 3 into 10 to the power 8. So this got cancelled out. So delta P comes out to be 2 into 10 to the power minus 6 kg meter per second. This is the change in momentum. So A option should be correct in this case. Okay. So this paper is done.